So my name is Huaming Qian. I work for Red Hat. I have been with the CNCF community ever since the day one. So I was one of these Kubernetes early developers and also participates the developments of some other CNCF projects such as Rook, Knative. And then most recently, I started restarted this project, Kepler, and other sustainability computing projects. So it's my pleasure to meet you all. So next one, maybe Marcelo.
Hi, I'm Marcelo Amaral from IBM Research Tokyo, and I've been also contributing to the Kepler project since I think the beginning, and I've been helping, with the code implementation review, especially for the collecting the metrics and also creating the power model, and I will be very happy to more contributors since we are joining CNCF.
Thank you. Maybe next one, Renjie.
Hello, everyone. This is Jie from Intel. I'm working in the Intel's software advanced and technology group's cloud software engineering team. Our small team's focus is on confidential computing and sustainable computing. So congratulations to all the guys here that our community has officially joined the CNCF Sandbox project.
Thank you.
Thank you.
Next one, Chen Wang.
Hello, everyone. I'm Chen Wang. I'm a staff research scientist from IBM Research, and I have been working with Huaming on Kepler since the beginning on research side. And then it's great. This project becomes CNCF project. Congratulations to all.
Thank you. So I'm just going to type your names if you have not provided your name here. Kai.
Yeah, I think it's good in the beginning of the meeting. We just say everyone to write their own name, so I think it's easier.
Yeah. All right, so Kai, cannot. Oh,
sorry. Yeah, I'm currently an intern at Red Hat. My main work was on the Kepler model server. So at the very beginning, I worked on some of the initial models for the Kepler model server, and I'm currently working on developing the XGBoost models.
Thank you. Maybe Pen, you can start next.
You mean me, right? I'm sorry for my long name, but yeah, my full name is Huaming, as already written there, so then I'm Gal, but just please call me Pan. I'm from IBM Research, Tokyo, in Japan. I also working with the Kepler projects almost in the beginning as well, mostly starting from the metrics collectings, but recently contributions is on the Kepler's model servers and the estimators for the power model. Okay, that is all.
Thank you. Sam?
Hello, everyone. Here's Sam from China, IBM System Lab. This is my first CNCF project. I'm very excited and together work with you guys. So as you know, I'm focused on the pipeline for Kepler and also some performance enhancement related things. That's all. Thank you.
Thank you. Peng Hui.
Hello, everybody. It's Peng Hui. I work on the Linux One hyperprotect service. I'm located at Beijing, and currently I'm working on the carbon calculation. I think it's quite similar the goal as the Kepler. And I joined the Kepler last year, and glad to work with you. In last year, I worked on the Kepler deployment, chart, and recently I'm working on the support on the ZHMC. And recently we created one demo, and currently I'm working on to put the code into the Kepler and to provide the support to the ZHMC. And that's all. Thank you.
So forgive me if I got your name wrong. So I'm really terrible with the names. So Yasumasa, you might just introduce yourself.
Okay, hello. I'm Yasumasa Suenaga from NTT Data in Japan. I'm very interested in measuring energy consumption such as Kepler. So because I want to use to run Java in Java as a Knative service in Knative. So yeah, I want to measure. So I'm very interested in this project. I'm happy to join this meeting. Thank you.
It's a pleasure. So Yasi, if I get your name right. Shiosi, sorry. Maybe you can just cannot hear you. Maybe I can just move on to the next one. Takuya.
Hi, how?
Hi.
Can you hear me? Yeah.
Yeah, I can hear you.
Takuya. Yeah. I'm Takuya Iwatsuka, connected from Tokyo, Japan. I work in the R&D department at NTT, one of the largest Japanese telecommunication company. I'm quite interested in Kepler because my team are now tackling with measuring and visualizing the carbon emission of software with Yasumasa-san, NTT Data. Anyway, I'm happy if I contributed to this project. Thank you.
Yeah, you're more than welcome to help us to make these projects better. Thank you. Yuma?
Yeah, hey, I'm Uma Devi and I'm part of IBM Research working from India. I'm not directly involved with Kepler, but I'm a product of I'm a part of the sustainable computing effort within IBM Research, and I've been working on carbon quantification, right, for VMs, and which has been integrated into Turbonomic and has been adapted for IBM Cloud also. In general, would like to know the current focus areas for Kepler to see whether we could leverage those or whether there are opportunities for us to contribute, particularly in GPUs, etc. Yeah.
That sounds great. Yeah, I believe there's going to be a lot of opportunities we can work together. Thank you, Yuma.
Thank you.
Rohan.
This is Rohan from IBM Research, primarily working in the area of resource optimization and sustainable computing, right? So the way we are approaching this is that, okay, you make certain optimization decisions for your environment, and then as a result of that, the reduction in the carbon footprint is a byproduct. So, so more looking at it, Kepler, from a lens of how do we quantify that reduction. So
that's great. For this name, I probably would you mind just start from your last name, because one of my best friend is using the same last name, Goya.
Yeah, hey, this is Anchal Goyal, and I'm part of Uma's team. I'm in India Research Lab, and I work on cloud sustainability with the Rohan, Uma, and the team. And like she said, our intent is, we work in carbon quantification on servers, on VMs, and recently we have started taking a look at the storage systems as well as, networks and so forth. So our intent is to understand how Kepler, the focus areas for Kepler and the ways to contribute and collaborate.
That's great. Thank you. Damien?
Yes, hello, I'm Damien Roux. I work for NTT Data based in Japan, and I'm happy to join today. And I'm a colleague of Suenaga-san, so I have the same motivation as him. And you misspelled Suenaga-san. It's S-U-E-N-A-G-A. Sorry. Yasumasa Suenaga. S-U-E-N-A-G-A. Just the line above, yeah.
Oh, okay.
No, the name just above, sorry. Yasumasa, just above, one line above.
Oh.
Yeah, this one.
Oh, okay, sorry.
And the family name, S-U-E, no, the second name. Yeah, exactly.
Okay. Yeah, thank you.
Yeah, sorry.
So hopefully with next time I will remember the names. This is my going to be my memory test. Yeah, maybe we can come to the agenda. So as you know, we just got admitted to the CNCF sandbox last month, and we are wrapping up to the onboarding process. So far, we finished 19 of the 21 required items. So the only remaining ones are the trademark transfer and the artwork. That's what we need to deliver to CNCF. But we are happy that we are get most of the stuff done. So we will get the Zoom meeting from the CNCF. Hopefully by the next meeting, the third Tuesday of the month, we can use the CNCF Zoom handle to have the meeting. And I will update the meeting calendar to reflect the information. So that's what we have. For the next one, I believe this is one of the things that the CNCF project started is for auditing of your software security. They provide services such as OpenSSF repo scanner and container image scanner to help us to build up the best practice in security. So we have some of the badges in place. So if you are going to the Kepler repo, we have the OpenSSF best practice here. We have not finished everything. So if you have bandwidth, if you have ideas how to make it better, just feel free to help us to get it into a better shape. The other thing is that in line with the OpenSSF best practice, we also have to have the version release. So that means for each of the repos that we are incorporating or just using, we use the release tags and aka the SHA, instead of just use the release branch. So that will put us into some of the, so previously, as you see, we have so many repos in each of the components. So we have the CI/CD pipelines, that will create the GitHub Actions. And for the GitHub Actions, one of the first one is a local cluster, local development cluster. And that one also recently gets a lot of changes. So when we use it, we do not know which the versions we are pulling into the Kepler CI/CD pipeline. So one of the first best practice we are trying to build up is to using the release tags instead of the main branch. So that's, you will see there's a lot of actions ongoing, including the pull request. There's a lot of GitHub discussions on the pull request as well. So if you can just join the discussion and share your best practice, that will be great. So my preference is that we take a stepwise approach. So we trying to use as many tags as possible. So that means there will be breaking changes in the CI/CD pipeline or the release scheduling, but that is all for the good thing for the future. So the first one, Renjie, do you mind just discuss the pull request you have on the platform validation? And we can start.
Sure. Wait a minute. Let me share my screen. Can you see my screen?
Yeah, we can see it.
Okay, thank you. Thanks. So let me. Sorry. Yeah. Yeah, this is my previous request for comments issue listed here. This is the ticket, and there is a related enhancement proposal document raised several days ago. And I'm very great appreciated for Sam and Marcelo and the other guys for constructive comments and suggestions. And I just updated one version to consolidate all those comments and to make things clear and simpler. Then we can move on and do some further works. And in this proposal, we just want to introduce a platform validation framework for the various of hardware platforms Kepler is supporting or will support. Yeah, and for this enhancement, we focus on maybe some new hardware platforms. In their early silicon phase, we can do some validation to prove that the platform is well supported in Kepler. Yeah, this is our initial motivation, and then we propose to have some test cases design and to define the whole workflow for such platform validation, and then to release a proper test report to prove that the validation is valid and Kepler works well on the specific hardware platform. Yeah, that's the major ideas and concept in this proposal. And we need to work with all the community guys to design more detailed test cases and to support more hardware platforms. And we want to make this such workflow, such mechanism as a general framework for all of the hardware platforms, including current running ones and the future ones. Yeah, that's all. For folks first time see this proposal, maybe you can read it carefully offline and then feel free to ping me for any questions or concerns. Thank you.
Thank you, Linjie. So do you have any questions so far?
Currently, I have no further questions. Maybe other guys can comment or have some concerns or anything else. I hope we can move on based on this one and to resolve the detailed issues or questions one by one, and to make this proposal or this framework robust and reliable in the future.
So here's Sam. So I want to just add some more information about this RFC. So the direction, or say the target of this proposal, I'm good to say that, and I'm glad with that. With the target, but currently it's just some proposal. So which doesn't mean, for example, as in the show here, we're going to use make script as cluster app. It's not finalized. So considering the real world, the different Kubernetes provider or different file paths, etc. details we need to handle as a long-term goal if we approve with this RFC. So I think it will start a long journey or further discussion if we can use the local development cluster as Kubernetes deployment script or something similar to do the validation. But let's see. Okay.
Yeah, I just want to
thank
have
you,
some. Yeah, I just follow up this discussion. So we see a lot of people who are using Kepler started with a client cluster because the Kepler has the dependency on kernel source at the moment. So the client cluster, if you are not configured in the best way, it may fail to pick up this kernel source. We have this in our CI/CD configuration, but that's why it's not well documented. So maybe we can also bring the documentation up to the front. So the way that we validate the platform can be also documented in some way. That's when people are using the client cluster or some other environments, they know how to get this done in the best way.
Yeah. Great.
We need to also mount the proc folder from the host in the client cluster. We do that in our script, but I didn't document that also anywhere. So there are some hidden tricks
configuration.
yeah, that's true. So we need to do that. But I think
I have some.
It's a good.
Sorry, I have some comments that was in the README of the local development cluster, but yeah, I do agree we should update it to our official document.
All right. Yeah. So I think for this PR, for this RFC, we can have it as soon as we, people are okay with the current status. So and then we move on to further details.
Yeah, I also believe that there will be several following PRs in specific details. For example, test case design and the test code implementation. Yeah, case by case, and we can make these things better and better in the future.
That's good.
And I also need community's help and suggestions. Yeah, I'm very appreciated. Thank you.
Thank you. So maybe you can move on to the next agenda. So KubeCon North America, and I think probably also the KubeCon China, the CFC is closing very soon. So maybe we can use the onboarding CNCF sandboxing opportunity to present what the project is about. So if you remember last time we presented to the CNCF tags, the runtime tag, the sustainability tag, we have this community-based presentation. So each one of us will have a recording of our own, and then we present everything to the tags. Maybe this time in KubeCon we can have some similar story. So each one of us share our story, and then the final presenters will present the whole story to KubeCon, and if we will get accepted. So would that be something that we all want to try? So in my opinion, if you're looking at the other KubeCon talks on specific projects, they will have deep dive sessions. They will have the projects update sessions. So we can use any of these formats, either deep dive or updates, to keep the community status open. In order to do that, let me share my screen. So my idea is, just feel free to share your proposal. So my idea is either we have the deep dive session, or have an update session. So these are two proposals I want to ask you for brainstorming. You don't have to decide it for now, but if you have any ideas how you can use Kepler, or how you think Kepler, the current status is, and you want to share with the community, with the CNCF community, maybe that could be one of the topics we can submit to KubeCon.
Yeah, I think that's a good idea, and I definitely want to submit one of these talks for the KubeCon. I think Supansan is interested to work on this submission of one talk as well.
Okay. Yeah. So we all cannot just working on certain updates. So the KubeCon, the nice thing with KubeCon is you can make modifications after the talk has been finalized. So if you are, for example, if you want to have deep dive sessions and you also want to bring up latest updates, you can still make that happen in the session. So if any of the end users or developers have some updates that we want to be incorporated into a session, and then we can make the decision. So the CFP close is this 18th in 2 weeks.
So Huamin, one suggestion: why don't we list down, all the possible deep dive topics here? Since most of us are already been here, so maybe you can discuss about that.
Yeah. So first thing I would think just reuse the talk we gave to the CNCF tags to deep dive into Kepler's architecture and each of the components, Kepler model server, and the training process. So we can introduce that as well. This is one of the things we can use. The other thing is based on what we are developing for the last 2 releases, 0.5 and 0.6, and we bring up the new features and new use cases.
So one topic I'm preparing right now is the foundation model system. So since we are building foundation model system and also adapting Kepler technology to take into account the the large language model or AI model, energy consumption. So I think once this is mature, I think I'll share that with you. I think I'll try to submit it by the time of the deadline. So of course I will work with Marcelo and Peng, and also other teams here, Chen and yeah.
That's good. Do we also have any of the end users adoption or use cases that we can potentially address in the future? So that could also be a very interesting topic to the KubeCon as well. Because KubeCon has a lot of interest in listening to the end user adoption. That could be a very good story if you can have any.
I see. So I think right now, since we are building this system, I think we don't have any specific adoption per se, but I think we have some use cases, so some of the use cases, of course, energy consumption for this foundational model system will skyrocketing. Okay. And then, how we have to reduce them. So I think using the Kepler, I think we can have a really nice story about that.
That's cool. And I think that's going to be a very interesting use case if you are able to say ChatGPT using energy accounting is able to find out the consumers of the energy and then reduce the energy consumption in total. That will be a very good story.
Yeah. So I think we have a whole story is about starting from the measurement to analyze it and also optimize them. So I think I'm not sure how much we can touch them, but so we have whole story from the measurement, which is the Kepler is working on, and so how we have to optimize them. I think that will comes later. Maybe I can briefly touch on how possibly we can optimize the energy consumption.
Sounds great. All right.
All right.
So I do see we have many people join the meeting the first time. So maybe I can just give you a quick update, a quick overview of how our community operates and what the Kepler's resources are. So we typically have a quarterly release planning. So for the 0.4 and 0.5, we have this using the GitHub projects board for planning. So if you have interest in any of these items and you believe that is something you can help, just feel free to sign up and we will work together to get them done. So the current plan for the 0.6 release is we are going to cast release either by August or September, depending on the progress. So 0.5 just cast last Friday, and we're going to have the 0.6 in a 3-month schedule. That's what we are going to happen. The second is that we have the Kepler website, which is based on the Kepler doc repo. So anything you think you want to add to the visibility or introduction or tutorial, just feel free to add to the make a PR into the Kepler doc, and then that will be visible as the website. The last thing is we have a lot of repos in the Kepler, as in the sandbox. I think this is probably the best way. So as you see in the sandbox application, the purpose of these repos are explained. So we have the model server, we have the estimator, and the energy and a workload repo that's trained models for the energy models. And then we have documentation, and everything here is already, you can find information about this repo, the purpose of this repo in the sandbox application. And one more thing I want to add to that, even though we using project Kepler for the CNCF projects, we actually do more than just energy measurements. We have this, if you are looking at the repo called Clever, that's this project is about autoscaler, using Kepler's metrics for autoscaling. So any of these projects you think that can help your environments and you believe you can make a contribution, just feel free to do so. And we are more than happy to work with you to make this happen. So Kepler itself is a daemon set. And we also have the model server, which is a deployment to train the models. And then eventually we get better models to use for help for the workloads that are running in virtual machines. So Kepler itself can operate both on virtual machines as well as the bare metals. This is the place model server will come in for virtual machines. And we also have the two different ways to deploy Kepler. One is through the manifest, the other one is through operator. In the operator case, there's a operator SDK as well as this Helm chart. So both of these deployment models are being supported. And if you have any use cases you want to, if you have issues and use cases you want to support, just open the issue or open a PR, and that's where make things happen. So far that's all.
So I mean, one question. So I think from this like a BMC integration, I think from your the tracking the issue, the GenHub. So I think you kind of deprioritize it or the backlog. So okay.
Yeah.
All right.
So this is still the feature.
Okay, I see.
Yeah. So I got my system yesterday, so I can work on the BMC system. So
okay.
That's, yeah. So maybe I
so
can.
Please put me the love. Yeah.
Okay, definitely.
All right. Thanks. Yeah.
Actually, this is actually in progress. Yeah. So we are still very interested in listening to the end user use cases and environments that you are running, so we can better help you to run Kepler and then help you to optimize the workload. At the moment, we still need a lot of help. We do not have some other systems, so ARM support is in progress, but it's not in a very good shape. If you have ARM system other than Ampere, so we currently support Ampere, but if you have other ARM systems you want to support, feel free to work with us, and so to make that happen. And then we also have people from Intel working on accelerators, but we do not have any other resources of working on specific, for example, the DPU or Smart Snake. This is something we do not have resources. So if you have the resource in your lab, in your environment that you believe that can help us, please just go ahead and open the tickets and work on these items. So as you see, there's a lot of ongoing requirements that have not been fully developed yet. We are still working hard to make them happen, but this community can become stronger with your help.
This is Peng Hui. I have a question about the BMC, HMC, IPMI, and currently we are working on that in parallel. And we may have the different speed. Shall we also track with this ticket, or we use a different one to track it later?
We can open the items, right? So right now it's in a single ticket, but maybe we should have multiple tickets instead of just one. So probably one for BMC and one for HMC, BMC.
Okay.
And so just to for some context, so many of these things, they seem trivial. For example, if you get the power from BMC, that makes itself seems trivial. But to correlate the BMC power with the workload, that is really a complicated process. That needs a lot of research activities as well as the development to make it happen. So I think our architecture is right. We have the model server. So hopefully we can build up models based on BMC power as well as the workload activities. We can estimate how much energy used by the workloads at the BMC level, which will include the network activities, storage activities, and the fan speed and the community sensors. So information like that will help us to pinpoint to the root cause of energy consumption at the workload level. So that's the whole purpose of using the BMC and HMC.
Yeah, indeed.
Okay. So do you have any information from everybody else? Like what's the use cases you want to hear, and what's we can help you to bootstrap the Kepler deployments in your environment? I see a lot of people from IBM and from NTT love to understand what's the use case in your environments and how we can work together. Just to relate to some of the previous experience we engaged with the telco. So I think the telco community has a very strong incentive to stay sustainable. So the most recently, some of the projects and some of the consortiums have put a lot of emphasis on power consumption, power accounting, so that they will know the environmental impacts from their deployments and trying to take actions to reduce energy consumption and carbon footprint. So if that is something that also aligns with our community, we will definitely want to spend more efforts on it. So if not, then maybe you can have quick updates on what we have accomplished since the 0.5. So Peru cast release, Peru, she's not here today. So she cast a release last Friday, and we have the 0.5 release. So if you are looking at the go to the Kepler's release, so the 0.5 was just cast last week. We have two releases. One is the container image. The other one is the RPM package. So you can install Kepler either through as a Kubernetes daemon set or install Kepler as a RPM package if you do not have a Kubernetes environment. So both deployment models are over there. Even though the RPM use case is not well tested. We have the CI/CD pipelines for Kubernetes, but do not have for the Red Hat Linux release. The other actions we have started is for the that is about the Renji's discussion about using platform validations for the testing and the deployments. So we have lots of discussions on it. So we have some ongoing efforts on the eBPF, on the eBPF side. One is that we're trying to eliminate the eBPF's dependency on kernel source. As you know, that we are currently using the BCC framework, so the BPF compilation collection, which uses LLVM to compile the eBPF program on the fly. The downside with that approach is that it requires the kernel header to compile the eBPF, which is not quite convenient for many of the end users. So we are trying to eliminate that dependency by using the pre-compiled eBPF modules. So we get some very good pointers, and we hopefully can take some actions to make it happen. The other one is we are trying to optimize eBPF use case. So at the moment, all the eBPF probes are invoked when you have a context switch. So we see that it happens too frequent. So we want to reduce the frequency by using sampling, and we are looking at how to make that happen. So that will be very beneficial for the real-time workloads, especially used by the telco customers. The other thing is ongoing is, as we just discussed, the BMC and HMC level power accounting So we want to get more power sources so we can have a holistic view of how much energy used by the workload. So that is also under development. So we also see people are trying to using Kepler and other frameworks or other APIs to calculate the carbon intensity. We had some early experimentation, and we demoed it at the Red Hat Summit to get the API calls from electricity board, and then use the carbon intensity and coupled with Kepler's energy accounting to get the carbon footprints of your workloads. If you are running a pod, we can show you how much carbon you use. And if you relocate your pod to a different location, based on a different carbon intensity, the carbon footprint will be different. So that's kind of a workload, that's kind of use case we also want to have people to start with. The ARM release and the S390X release will come up with its own CPU architecture. So we are trying to have this multi-arc build process in place. It's still work in progress, but we hopefully can resolve this by this release. Yeah, that's most of our ongoing developments updates. So that's 4.6. We still have some quite ambitious goals for this release, and given how many people we can work on the projects, that is still very ambitious. And if you can join the community and share your expertise, make the development faster, that will be a good news. Okay, so anything you want to have updates or just want to share your story?
So one topic I was wondering is, how we can adapt the Kepler on the DPU or the smart NICs. So I think you briefly mentioned that, Intel might be working on that, but, how we can adapt the Kepler on that specific device. And I was just wondering if someone can comment on it, that might be very, very good.
Yeah, definitely. So we'd love to have this use case as well. So we see a lot of reports that the DPU saves a lot of energy, but to what extent and how we can attribute that energy reduction to workloads is still a very interesting story.
Yeah, exactly. Such DPU, and I think the principle for such DPU is similar as our other CPU built-in accelerators. The major purpose is to offload the computing from CPU to specific hardwares.
Yeah.
And as I know, in Intel, there are specific BU to work on such DPU. And in Intel, the name is not DPU, but another name called IPU. Infrastructure per process unit. Yeah. If the community has any interest, I'm happy to contact with our other colleagues here to get more information. Yeah.
That's really good.
We can discuss offline.
Okay. Sounds great.
So is that only the measurement, or I think, you're expanding to optimize the power consumption from the DPU or IPU itself? For example, once you offload some of the functions to DPU or the smart NIC, then I think you most probably, utilize them 100%. For example, the DPDK or SPDK, that kind of library, you want to offload them, to the smart NIC, then, most of the time they are, 100% running. So then this like optimization capability might be very minimal because, there are limited idle cycle in DPUs on IPU.
Yeah, I think
of course
Yeah,
so I think, I totally agree that so DPU or IPU will be more power hungry in the future. So because, a lot of people in the cloud domain or, lots of devices want to offload lots of function to the DPU. But I think how much we can save energy from the DPU, I'm having a question about that.
Yeah, I read some of the research papers. They made a claim like 30% power reduction. I'm not, because I don't have the same environments. I don't know if that is true.
Yeah, so basically what they're claiming is, when you offload them, of course, you're not using the host side CPU cycle so that you can save energy. That is good, but that energy saving came from the host side, not from the DPU side, right?
Yeah.
Yes,
Yeah. So
actually, hardware efficiency is not equal to energy efficiency. Yeah.
Exactly.
Frankly
Yeah.
speaking, just for our CPU built-in accelerators, not all of the accelerators save energy. We are doing there are some investigation undergoing in our projects, and we may show our progress in the next few weeks for the CPU built-in accelerators energy efficiency evaluation. Yeah.
That's very interesting.
I just posted the research paper here. It's still relevant, 2019. So maybe you can take a look at how much they can, how they made the statements and what type of savings they are projecting. So that could give us some direction.
But I try to, I think include the Kepler on top of this, right? So I think, so adapting Kepler on DPU might be different story than, energy savings because, so DPU itself, may not save energy, right? Right.
No.
So DPU will reduce the system power because they are offloading host cycles to the DPU, right? So, for sometimes, the DPU may run much more efficient, and also they can do lots of hardware acceleration so that overall they can save system power. But I think the Kepler here, I think we are talking about adapting that.
Still already on the host.
Yeah. Yes, exactly.
Yeah. So we still, there's no plan to migrate Kepler to the DPU yet. So we just want to run Kepler on the host and see what's the potentials of using DPU versus just the system itself. In terms of energy saving.
I think it's possible. Maybe DPU is most probably is ARM processors. Then once we develop ARM processor, the power measurement, I think we can of course read the DPU. Of course, you have to think about all the security issues and everything. But
yeah. So as I just mentioned, we have a early experimentation. So Ampere right now for the Ampere CPU, but we do not have yet. So if you are running the Mac M1, M2, Kepler cannot run its own over there. If you are running on Graviton, there's no way Kepler can know the energy. So that is one of the things we hopefully can get the support from the community.
Is the Graviton CPU support any power reportings or?
They must have one because when they say when Amazon reports the energy saving, reports each of the Graviton generations, they always report the energy saving. So they must have a way to measure the energy from the CPU.
I see.
Yeah, but for Mac, there's some there's no C group on Mac, So either Mac or Windows, as as discussed with Renjie through the platform validation proposal. So sounds like another story and lots of things we need to figure out. But maybe one more thing here for today. So as we have some RPM binary release, so is there any, as Kepler itself is a Go project and supports cross-platform build, so is there any plan for us support maybe S390 or other build in 0.6 release? I mean, maybe not Docker image, but just
the binary.
Yeah.
That's a very good question. I have not seen so I personally have not seen the S390 myself. I think it's possible to build one, but I don't know how to run it or build one on my own. So if you can just experiment how to build it, that would be great. So the RPM release at the moment consists of two forms. One is to run the binary inside of a Docker container. So that will be very similar to Kubernetes. The other one is to just run it as a standalone binary. Running as a standalone binary means that we have to have all the dependencies, the RPM dependencies installed on the RPM as well. So fortunately, there are not too many, but if you're using it on some certain other environments, we don't know. Yeah, if you have any access to the S390 and build a binary, we are happy to incorporate it into the release.
Okay, I got it.
Right. Any more discussions? As if not, then maybe we can just miss each other in 2 weeks as a different time zone. And happy to see you all here, and hopefully we can make Kepler great and